Translate the argument into symbolic form. Use a truth table to determine whether the argument is valid or invalid. Here's the argument right here. If it is Friday, I do not work late. That's a conditional statement. And I work late. So these two statements above the line, you put them together with the word and. So if it is Friday, then I do not work late, and I work late. This is the therefore symbol. Therefore, it is not Friday. It wants us to write this in symbolic form. I'm going to let P be it is Friday. So the top piece is a conditional statement, if-then statement. If P, then, and I'm going to let I do not work late be Q. So if I let Q be I do not work late, then I work late is the negation of that. So the second line is going to be tilde Q. That's the negation of Q. Therefore, it is not Friday is the negation of P, which is it is Friday. So this would be tilde P. Now we're going to make a truth table. We need to combine these with the symbol for and then the therefore, it's like an if, this and this, then the negation of P. So we need a truth table involving P and Q here. So we have four scenarios. We have the case where they are both true. We have the case where P is true, Q is false. P is false, Q is true. Or the case where they are both false. Now I need the conditional, if P then Q. Let's make a column for that. This one only has one false scenario. That's if I go from a true statement to a false statement, which is this second one down right here. All the other cases will be true for the if-then statement. All right, now let's make a column for the negation of Q. This takes the Q column here and does the opposite, so it would be false, true. Now I'm going to put these together with the symbol for and. So I'm going to put parentheses around if P then Q, and then I have the and symbol, and then not Q. So I'm looking at these two columns right here. When you combine two statements with the word and, it's only true if they're both true. So you're looking for cases where they're both true, and there's the bottom one here. All the other scenarios will be false. All right, now I'm going to make a column for the negation of P. That takes the P column and does the opposite. It would be false, false, true, true. All right, now I'm ready to put it all together into this argument right here. It's going to be if this, then this. So I'm going to use brackets. If P, then Q, and the negation of Q, then the negation of P. So I'm checking this column. Remember, it wants us to determine whether the argument is valid or invalid. Now, if I get all trues here, then this argument is true no matter the scenario we are in. So if it's all true, then we're going to say the argument is valid. If we get at least one false, we're going to say invalid. All right, so this is an if-then statement. I'm going from this to this. If-then statements there's only one false case if I go from a true to a false. Do I have any true to false scenarios? No. That means they're all going to be true. And since it's true for all scenarios of P and Q, we're going to say the argument is valid. Which makes sense if you think about it. If it is Friday and I do not work late, and I work late, then it is not Friday. That makes sense. There you go.